Okay, so here we go with a brief overview of geocoding, geo-enabling our address data to create a new GIS layer. I, by all means, do not want this to be too much of a lecture. I just want this to be a quick overview. And so I want to refer to you guys to page 444 and 445 in the green GTK book. Basically, the next several slides sort of summarize everything that they're talking about as you lead into chapter 17. Geocoding addresses. So what we're doing here is sort of overviewing the concept, let you guys practice it in chapter 17, and then move on to assignment number 6 in your case, where you're actually going to create a map from addresses that you geocode. So what is geocoding? Well, the process of creating map features from addresses, which is what we're going to be doing, but you can also do it based on place names or other known locations. You'll see in a second here how maybe another known location might be the centroid of a zip code, for example. So you can see here on the left-hand side we have a table, and the arrow indicates that we're going from tabular information over to actual geospatial information, not unlike the way we did for assignment number 2, where we took XY coordinates that we took off of a website for earthquakes and created point locations for them. In this case, we're taking address data and making some sort of connection, if you will, to data that will tell us where those points are located. So a little bit different. So we'll go through that process and sort of explain how that works. So if you're looking at page 444 and 445 in the green book, as I make reference to several things on those pages, it would be good to do so and have that available while you guys are looking at this brief overview. So you need to have 3 things to be able to do geocoding. And so, of course, the first thing, the most important thing, of course, is addresses. Maybe you are some sort of a business and you maintain your addresses for all your customers, or all the times that they've come in, they've given you their address information, you have that on record. And so you have stored that in some sort of a database, maybe a table, DBF, in Excel, etc., some other tabular format, or even a text file. So you can see, as we say here in the next bullet, that is a flat file. That is you guys have heard me use that term before, where we have no geometry. But I say in that second bullet, no geometry yet, because the process that we're learning here is getting us to the point where we have points, point locations for these different addresses. So what we're looking at over here on the left-hand side is just a very basic address table. In this case, it happens to be a DBF that I opened up in Excel. So you see the very familiar Excel window. You see the column headings across the top, and then, of course, each individual row indicates some sort of address. In this case, this happens to be the names of several folks that I used to work with, and then several bogus addresses that I just pulled out that actually are real addresses in the real world, not really associated with those folks, but for demonstration purposes, and we'll see this in the demo in a few minutes. These are all addresses that are going to actually geocode correctly, and so you'll see me refer to the hunkydory.dbf, because in a perfect world everything is just hunky-dory. So you can see the same exact file over here, hunkydory.txt. So in this case we're talking about a text file, or what we call a tab delimited text file. So there are tabs in between each of the column headings, and so there's a tab with its corresponding information in between as well. So you could actually geocode a text file as long as it's formatted properly. You could also have commas be the delimiters as well. In the case of our demonstration, we're going to be geocoding a couple of DBFs. In the case of your assignment, you're going to be geocoding from an Excel file that you create at the very beginning. So again, just a couple of ideas or a couple of examples here of how we take flat file data and eventually we create geometry in the form of points for our locations. The second thing that you need is reference data. Reference data is extremely important, and so that's going to take the form of some sort of a GIS layer that has information with some location information in it. Primarily in our demo, in your exercises, and in your assignment, you're going to be doing roads with address ranges. So the attributes in the attribute table in the DBF for a particular shapefile of roads is going to contain the address range information. So if you can imagine how addresses are arranged in the real world, you go down a street, you've got your even on one side, your odd on the other, and they increase by increments of 2. So we'll see that in our demo as we look at some data here in just a few minutes. Zip code points are polygons and points with place names. You may not be interested in getting it down directly to what address point location is. You may just be interested in finding out how many occurrences of a particular address happen at the zip code level, or even matching to a point shapefile of place names. Matching a list of place names that you have so that you have some sort of geometry to show in the real world. So this is an example of roads with address ranges. So I'm going to kind of draw your attention up towards the top here, starting from this corner here and moving our way down. We're at Jefferson Street Northeast. Jefferson Street Northwest goes in this direction. So we're starting here. We can see we have the right side and the left side of the street. And we have the 100 to 102 range and the 101 to 103 range, 202 to 212, 201 to 213. So our odd side is going to be along this side, and our even side is going to be along here. So if we were to actually try to geocode, say, 206 Jefferson Street Northwest, so that's going to be an even side of the street, and it's going to be about halfway between 202 and 212. It would place that point approximately halfway in between. So that's what the software is basically doing for us, interpolating and looking at the reference data and trying to estimate essentially where your address location should be, and it does that all in one layer, creating one layer of all of your point locations. And we'll talk about some of the exceptions in general, if you will, to that rule. Another way to do it, of course, as I mentioned earlier, was to geocode to zip codes. This is an example of zip codes in, I believe it's Omaha, Nebraska, and the stars basically indicate where my addresses have geocoded to. So in this case, I may be doing a more general analysis, and I don't necessarily need to have the locations of my points nailed down exactly to what address in the real world it is, more so nailing it down just to the centroid of zip code polygon. So you'd like to use the example of Disney. A lot of times when you walk into a Disney park, they ask you very quickly what your zip code is. Not many people are really interested in giving away their entire address information, but most people are willing to say 21213, 68112, whatever your 5-digit zip code is. And so they're doing more of a national analysis potentially to see where their clientele is coming from. So I'll kind of keep that context of customers throughout the demo as well. But you got to remember that when you geocode to a zip code, that's the only thing that you have to geocode to if you're just using zip codes. So it's going to place a point or a stack of points. If you have multiple addresses with the same zip code, you're going to have multiple points that are stacked right on top of one another at the centroid of that given polygon. But again, if you're just doing a more of a regional or national analysis, this may be the appropriate level or scale that you may be mapping at. And so the bottom of page 444 sort of illustrates that with both a road network but also with a zip code graphic, not unlike what we're showing here in the overview. The third component that you require is an address locator, and you can see my graphic over here is just a shot from our catalog. Here's the the geocoding demo folder. I've got an address locator folder, which you're going to see in the other demo, and then here is a file called MD Roads. And a little house with sort of a little tiny lawn on it. So that indicates that this is an address locator. And so what an address locator is, it's a sort of a file that kind of acts sort of as a connector to your reference data. So your reference data, it tells you as the user tell your address locator what your reference data is. Are you using a zip code layer? Are you using a roads layer, etc.? There's going to be important attributes. In the case of geocoding to zip codes, the zip code field is obviously going to be the key attribute there. But if you're geocoding to roads, then you're going to need to know in the fields of data in your reference data layer what the left side range, what the right side range of addresses are, and the from and to range from the start of the road to the end of the road. Again, mimicking how addresses actually behave or are laid out in the real world. So this is, again, these first 2 points indicate that you're making some sort of a reference to the GIS data or the known GIS data that has your geometry and your attributes that will allow you to geocode. The address table key attributes are important. So what what attributes in your address table are you using to check against your reference data. So if your address is contained within a field called address, then you want to tell the address locator that's the field you want to look in. A lot of times ArcGIS is intuitive enough to know which address field it is, and it'll take a guess, but sometimes you may have multiple address fields in your table, and so you're going to have to direct it and let it know which field to use. And so you'll see that in the demo here in the next video. Geocoding rules and tolerances. There are a couple of other settings that you can indicate in the address locator that is basically going to allow you to set up a few other settings, if you will, about your geocoded data, other output fields that you can include, and sort of tolerances, if you will, for do I want the point right on the line, or do I want it backed off by a certain distance on either side of the road, for example. So again, when we look at the demo, we'll see what that means. So this address locator, as I mentioned earlier, creates a connection between the reference data and the address table to be geocoded. So that's really important. And I put connection in quotes there because it's not really connecting the data in any way. You're just making references. Again, you're telling the address locator, here's the reference data layer that I'm using, and then you're also telling it in the address table, which again is highlighted here in bullet number 3. There's going to be certain attributes that are going to hold my address information, and that's where I want you to look. So that's essentially what this locator file does. And of course, that is created in our catalog, and our demo will illustrate that. So you're not actually creating an address locator in ArcMap, you're doing it in our catalog, but it does get used in ArcMap when you actually do go through the geocoding process. A couple of other things about the address locator to wrap up here. You do have options. You can create your own locator. So for example, this is a locator for a file of Maryland roads that I'm going to use in my demo that I created that references a layer on disk. However, ArcGIS Online also has its own locators, and you can take your own address table locally and use online locators to try to locate where your addresses are. This is a service that has become available in ArcGIS 10 and will probably continue to be so moving forward. So it's a nice handy dandy thing that ESRI has put out there for us to be able to connect to their servers and to their data without having to go through and create our own address locators. And then using a geocoding service locator. A lot of people put services out there that you can connect to, and then you can take your data and compare it against their geocoding service. I will mention MD-IMAP, Maryland's IMAP. You'll see that in assignment number 6. And it'll give you a URL that you'll be able to visit and make a connection to MD-IMAP, and you could even use their locators to try to locate your addresses. In that case, that's data from all of the local counties that's being pushed up to the state level. And again, as I may have mentioned earlier in the course, a lot of times the best data is going to be at the local level. So if the locals are maintaining their roads at the best level and they're sending it up to the state, we then have a Maryland statewide locator that we can use to do geocoding in Maryland as well. You don't have to create your own locator. You don't have to have your own reference data. That geocoding service helps you do that, or allows you to do that. So those are options, and all 3 of those are going to be part of the assignment. You have a choice to use any one of those. They are all at your disposal for the assignment. A couple of things about geocoding just to wrap up here. I do want to point out it's not an exact science. You're going to have issues. You're not going to match 100% of your addresses all the time, and that could be a function of a couple of different things, and the first one's going to be the reference data. In fact, the reference data that I'm going to give you is a roads layer for Maryland that is several years old. It's probably over 10 years old now, but it does have the information in it that is required for geocoding for demonstration purposes and for doing some lightweight geocoding. However, you can imagine how much development has gone on in an area over a period of 10 years. Maybe new developments are built, new roads are built, and if the GIS data is not kept up to date, then some of your records are not going to match. And the last thought here with records not matching is the address data. For the assignment, you're going to be at the mercy of your own data input. You'll see that in the assignment when you see the instructions on what to do. But you may get an address table from a client. There may be 1,000 addresses, it may be 100,000 addresses, it may be 20 addresses, and depending on how well they've entered their address information, it may or may not match with your geocoding reference data. And so that's why I say it's not an exact science. There are some limitations. We did a project a couple of years ago for the Community College of Baltimore County where we mapped all the students, over 70,000 students, and we got about 57,000 records that matched. So there was about 11 to 12, 13,000 records that we had to deal with, and we either had to disclaim in our analysis that we weren't able to locate them, which indicated to them that they might have some issues with some of their address information, but it also indicates that there may be a certain level of manual work that you need to do to fix some of those addresses so they match. And so you'll get an opportunity to do that through the exercises, and hopefully not too much through your assignment. You'll put in good addresses and they'll match, and you'll be able to make the map that is required for the assignment. So again, meant to be less of a lecture and more of an overview of those pages 444 and 445. Those are the two pages that lead into the exercises, and again, just a few pointers, some things to think about while you're going through the geocoding process. So what I'm going to do is move over to the other video now and actually demonstrate the process, and then you guys can get moving on with your exercises and with assignment number 6.